4.5 billion years ago, a planet the size of Mars named Theia collided with Earth. A piece of our globe broke off, became the Moon, and has been orbiting nearby ever since. Have you ever wondered what would happen if this movement suddenly stopped and our satellite fell back to Earth? It would surely be a spectacular event. Some might say that the Moon isn't that big. Well, it only seems that way. Here's a picture showing Earth and its satellite to scale. It shows that the Moon is actually quite large. The surface area of Earth is 510 million km², while the Moon's is 37.9 million km². That's larger than the area of the African continent, 30.4 million km². Just to reassure you, don't worry, this rocky giant isn't going to fall on us. Moreover, it tends to gradually move away from Earth at a rate of 3.78 centimeters per year. According to calculations by astronomers from the National Radio Astronomy Observatory, it would leave Earth's gravitational influence in about 15 billion years, though by that time, the Sun will have entered its red giant phase, and we will have other concerns. The Moon orbits Earth at a speed of 360,000 km/h, about 1 million kilometers, completing a full orbit in 27 days. But what if we slowed down the satellite's speed, and instead of stable orbiting, it started falling towards Earth? Let's leave the questions of how and why for later. For now, let's just observe the results of the experiment. There are two ways to drop the Moon onto Earth: slow and fast. Let's start with the first. We will gradually slow down the Moon so that it loses, say, 10 km/h in speed each day. Then our satellite will slowly descend to a lower orbit and collide with Earth in about a year. The first thing the Moon will affect is the tides. They occur because the satellite, orbiting Earth, attracts masses of water in the world's oceans. The Sun also influences the tides, but to a much lesser extent. As the Moon moves lower, the tides on Earth will become higher and higher. The height of the tide is proportional to the distance from the Moon, says Neil Cummins, a physicist from the University of Maine. If it were, say, twice as close to us, the waves would be 8 times higher. Many coastal cities, London, New York, St. Petersburg, Tokyo, and so on, would be flooded. If you think you're safe inland, you're mistaken. The destruction of coastal cities would make shipping impossible, and thus the supply of food and other goods across the planet would be irreversibly disrupted. Additionally, coastal communication terminals and data centers, which connect all continents via underwater cables, would be flooded. Very soon, humanity would be left without the internet, and global trade and the financial system would collapse. But that's just the beginning. The Moon will affect not only water but also land. Its gravitational field causes the movement of the Earth's crust. The approach of the Moon will lead to constant earthquakes, cracks in the Earth's crust, changes in the landscape, and volcanic eruptions, as if a global flood wasn't enough. On the internet, you can find a video titled, "What if the Moon were at the same distance from us as the ISS?" That's 420 km. It looks impressive. If you ignore the fact that there would be tsunamis, tidal waves several kilometers high, and erupting volcanoes below. But this video doesn't accurately depict the situation for another reason. It's not just the Moon that affects Earth with its gravity. Our planet also influences the satellite. At a certain point, the descending Moon will reach the so-called Roche limit. This is an orbit so low that the celestial body cannot maintain its integrity. For the satellite, this height will be 18,400 kilometers from Earth. When the Moon descends to such a low orbit, Earth's gravity will tear it apart and turn it into a ring of debris and dust, similar to those surrounding Saturn, only smaller. Do you think this will save us? Well, not quite. Although the whole Moon won't fall to Earth, tens of thousands of its pieces will crash onto our planet's surface. Long ago, 66 million years ago, a meteorite struck Earth creating the Chicxulub crater. It triggered a mass extinction, wiping out 80% of all animals living on the planet at that time, including the dinosaurs. The fall of the Moon's fragments to Earth will be an even more destructive event. Numerous meteorites will not only cause enormous damage themselves, their collision with Earth will throw hundreds of tons of dust and gases into the air. These, in turn, will cause acid rains, block the planet's surface from sunlight, disrupt photosynthesis in plants, and bring about a new ice age. Will life on Earth survive? Yes, extremophile bacteria and cockroaches have survived in such conditions before. Humans might also survive if they manage to dig deep enough bunkers during our experiment. And when the dust settles, they will emerge onto the frozen Earth's surface and wait for it to thaw, which will take millennia. Well, at least they will be able to admire the rings around the planet, the only reminder that we once had a moon. But what if we don't slow down the moon gradually, but stop it quickly enough, but not instantly? Because otherwise, the celestial body might tear apart due to kinetic momentum. In this case, the satellite won't descend in spirals gradually, but will fall straight down. And then it will all end quite quickly. If the moon starts falling right now, it will reach Earth in 2 hours and 28 minutes and crash into us at a speed of 313,200 km/h. Atmospheric resistance can be neglected here because the celestial body will travel most of the way outside it, and when it enters the dense layers of air, they won't slow it down. Planetologists from Durham University in North Carolina used the COSMOS supercomputer to simulate what happens when two planets of different sizes collide. If the moon falls to Earth, the impact force will be such that the oceans will heat up and boil, and the atmosphere will be blown into space. Naturally, no one will survive such a cataclysm. Therefore, it's better to leave the moon alone.